I'd like to use this video as an opportunity to introduce you to Numbrix puzzles, which are really fascinating puzzles that we'll be using as our motivation for programs this week. Now, before I show you the puzzle, I'd like to tell you a little bit about the person who's responsible for creating Numbrix puzzles. They're fairly new. They were invented in 2008 by Marilyn Vos Savant, who's a columnist for Parade magazine, and I've included her picture here. She is an absolutely fascinating individual. So I've included an article that links on the bottom right here. If you'll take a look at it, Marilyn Vos Savant is the world's smartest woman, according to the headline. In fact, Marilyn Vos Savant is the world's smartest person with the highest IQ ever recorded. And yet, many people have never heard of her, and her intelligence is often vastly underrated, as evidenced in this article. So where I first heard of Marilyn Vos Savant was not as a columnist for Parade magazine, but as the known solver of the Monty Hall problem, a hugely controversial probability problem that's very simply stated, but has an unintuitive paradoxical solution. And that's a fascinating story, which is outlined in this article, which is why I've included it, but it isn't the story of Parade magazine and Numbrix puzzles, which is what we'll be taking a look at. So let's return to those. A Numbrix puzzle is a grid type puzzle with the numbers 1 through 81 appearing in every one of the cells in a 9x9 grid. The goal of the puzzle is to fill in the numbers 1 through 81 into the 81 squares of the puzzle consecutively using horizontal and vertical movements. So in the end, what we need is a path connecting 1 to 2 and 2 to 3 and 3 to 4 and 4 to 5 all the way up through 81, where we're only ever moving either vertically or horizontally between cells within the grid. So for example, if I start at the cell containing 1, which is a very good place to start, I see that 1 and 3 are values that are already filled into the Numbrix puzzle, and I somehow need to get from cell 1 to cell 3 by moving horizontally or vertically. From glancing at the puzzle, we see that the only way to do that is to fill in this red circled cell with a value of 2. And we could go on from there saying I then need to get from cell 3 to cell 5. Those are located diagonally from one another. So the only way to accomplish that is to move to the left one value, put a 4 there, and then travel up to the 5. And from here, it's not entirely clear where we go next. The 6 could be located either there or there at first thought, and we would need to continue logically making deductions about where the 6 belongs in this puzzle. Now, just to emphasize this point, I'd like to show you what it looks like when you complete a Numbrix puzzle online from Parade magazine. So here I've taken a Numbrix puzzle and I've filled in everything except the last entry. Taking a look at what's missing, we can see that the 25 and the 27 need to be connected via a 26. And it will show you once you've typed in that last value, the horizontal and vertical movements necessary to connect all 81 pieces of the puzzle. Like so. Voila. And in fact, if you're interested in working some more Numbrix puzzles, Parade magazine has a whole list of puzzles that you can access, and it'll do that very satisfying trick at the end when you've completed them. But I'd like to return to the Numbrix puzzles that we'll be looking at to show you the strategy we'll be programming this week. So here's an example of a Numbrix puzzle. In fact, the Numbrix puzzle that I just completed online and showed you that path for. I want to talk about the strategy that we'll be doing, just sort of a process of elimination strategy that you would use towards the end of any kind of completed Numbrix puzzle. So when I first started this puzzle, my thought again was to start at the very beginning, but there is no number 1 or any number 2 present in the values that are filled in the Numbrix puzzle. But I focused on the number 3 right down here. And as you can see, the cell 3 here connects to a 4, but it's not connected to a 2. So one of these other 2 cells, which are adjacent to cell 3, must contain the value 2 in order for this to be a valid Numbrix puzzle. However, the value to the right of the 3 is an 18, which isn't a 2. So I've got the 4 over here, the 18 over here, and only one spot left in the entire puzzle where the number 1 smaller than 3 could go. And so the 2 has to go in this location right here in order for this to be a valid Numbrix puzzle. And particularly well suited for this particular puzzle is that strategy all over around this border. All of these border cells are filled in, and for many of them, there's only one option for where another number could go. And if that number is not already connected to a number 1 smaller and 1 larger than it, we know exactly what needs to go in that last remaining cell. So that sort of process of elimination strategy is what we're going to focus on programming this week. Now, I'd like to point out that that's a good strategy and it's very useful, but it doesn't cover everything. In fact, that puzzle that I started with at the very beginning, there aren't any cells in this initial Numbrix puzzle where we are forced into what needs to go into the last remaining cell next to it. Because of the way that these are laid out on the board, not a single cell has sort of 3 out of 4 or 2 out of 3 of its adjacent cells or neighboring cells filled in. And so that trick is very useful for the type of puzzle on this page, but not very useful for the initial state of the Numbrix puzzle here on the right page. So we'll be working through that this week. In my next short video, I want to show you in Excel how to make this happen. But for now, that's our introduction.